Hi everyone, my name is Oluyemi and I am your tutor for today on chemistry. Today on chemistry, we'll be looking at rate of reaction. Under rate of reaction, we'll be looking at rate curve and the collision theory. And lastly, we'll be looking at factors affecting rate of chemical reaction. Now, let's take a look at the meaning of rate of reaction. The rate of a chemical reaction is the number of moles of reactants converted or products formed per unit time. Usually, rate of reaction is determined experimentally by measuring change in concentration of one of the components in the reaction with time. Thus, rate of reaction is equal change in concentration of reactants or products, that is mole per dm cube, over time taken for the change in seconds. The unit of rate of reaction is mole per dm cube per seconds or gram per dm cube per seconds. Rate of reaction can also be expressed as rate of reaction equals change in number of mole or mass of reactants or products over time taken for the change. Then the unit of rate is mole per seconds. Example: when 0.5 gram of calcium trioxocarbonate 4 was added to excess dilute hydrochloric acid, carbon 4 oxide was evolved. The complete reaction took 5 minutes. What was the rate of reaction? Solution: rate of reaction equal change in mass of reactants over time taken for the change, that is 0.5 minus 0 gram over 5 times 60 to give 0.5 over 300, which equals 1.67 times 10 raised power minus 3 gram per seconds. Now we move to ways of measuring reaction rate. Concentration is one of the properties of a reaction that can change with time. The following properties can also change with time and can thus be used to measure rate of reaction. 1. Decrease in mass of reaction system. 2. Volume of gaseous product. 3. Amount of precipitate formed. 4. Change in color intensity. 5. Change in pH. 6. Change in total gas pressure. Now we look at rate curve. The rate curve is a graphical illustration of the rate of a reaction. The following graph illustrates rate curve. Features of rate curve. It passes through the origin. This is because there is no change in concentration or mass at the start of reaction. It is steep at first. This is because the rate is fast at the beginning. 3. It becomes less steep later. This is because the rate slows down. And finally, it becomes horizontal. This is because the reaction has reached the end point. The following can be determined from the rate curve. 1. Average rate of reaction. Average rate is given by total number of mole or mass evolved over time taken. 2. Rate at a particular instant during the reaction. Rate at instant is equal to gradient at a point on the curve. When the rate of reaction has direct variation with concentration, rate is directly proportional to concentration A. Introducing the constant K, rate is equal to Ka, where K is called rate constant. Now we quickly move to collision theory. The collision theory states that for a chemical reaction to occur, the reactant particle must collide, and they must collide with a certain minimum amount of energy known as activation energy. Reacting particles are in continuous motion, thus they possess energy and they also collide with one another. Not all collision results into chemical reaction. Collision which results into chemical reaction are called effective collisions. Minimum amount of energy required by reacting particles for chemical reaction to occur is called activation energy. Activation energy is the energy barrier the reactants must overcome for reaction to occur. It is the minimum energy required for bond breaking for chemical reactions to occur. Chemical reaction occur only when the energy of the colliding reactant particles is equal to or more than the activation energy. Activation energy must be equal to energy barrier also for chemical reaction to occur. Every reaction has its own energy of activation. Reaction with low activation energy have high rate of reaction and occur spontaneously. Reaction with high activation energy have low rate of reaction and are not spontaneous. Now, we look at factors affecting rate of reaction. From the collision theory, it can be seen that rate of reaction depends on the following: 1. The energy of the particle. 2. The frequency of collision of the reaction. 3. The activation energy of the reaction. These features of a chemical reaction are in turn affected by some factors which can make them to change and consequently affect the rate of reaction. These are factors that affect the rate of reaction. Some important ones are nature of reactants, concentration or pressure for gases of reactants, surface area of reactants, temperature of reaction mixture, presence of light, and lastly, presence of catalysts. To study the effect of any of these factors on rate of reaction, all other factors must be kept constant. Now let's look at effect of nature of reactants. If all other factors are kept constant, different substances will have different rate of reaction with dilute HCl. For example, when dilute HCl reacts with zinc, iron and gold under the same condition, hydrogen gas is evolved fast with zinc, slow with iron, and no gas is evolved with gold. The difference in rate of reaction is due to the chemical nature of the elements, as they naturally possesses different amount of energy content. Effect of concentration of reactants. The frequency of collision among particles is high when the particles are crowded in a small space, that is, high concentration. This leads to high effective collision and thus high rate of reaction. An increase or decrease in the concentration of the reactants will result in corresponding increase or decrease in effective collisions of the reactants and hence the reaction rate. Effect of surface area of reactants. This is very important factor to be considered when a solid is involved in a chemical reaction. Lumped solid offers small surface area of contact for reaction, while powdered solid offers large surface area for reaction. Rate of reaction is low with lumped solid but high with powdered solid. Now we look at effect of temperature. Increasing the temperature of a system can lead to an increase in reaction rates in two ways. When heat is raised, energy in form of heat is applied and supplied to the reactant particles so that the number of particles with energy equal to or greater than the activation energy increases. 2. The velocity of all the reactant particles increases due to the greater kinetic energy, leading to a higher frequency of collision. As a result, the number of effective collision increases and the reaction proceeds at a faster rate. Decrease in temperature leads to decreased rate of reaction. Now we look at effect of light. Some reactions are influenced by light. The rate of reaction is high when the light intensity is high, low when the intensity is low, and does not proceed at all in the absence of light. Such reactions are known as photochemical reaction. Examples of photochemical reactions include reaction between hydrogen and chlorine, decomposition of hydrogen peroxide, reaction between methane and chlorine, photosynthesis in plants, conversion of silver halides to grey metallic silver. Effect of catalyst. A catalyst is a substance which alters the rate of a reaction but itself does not undergo any change at the end of the reaction. A positive catalyst increases the rate of reaction by lowering the activation energy of the reaction, whereas the one which increases the activation energy is known as a negative catalyst or an inhibitor. Now we have come to the end of this class. I hope to see you in the next class. Thank you.